So I received a number of questions on ammonia toxicity. It seems a lot of you guys were asking exactly how you're supposed to answer the question on ammonia toxicity. So the question was asking for biochemical interactions that lead to ammonia toxicity. And of course, I want to mention that this question is independent of the other question on obesity. So you answer this question on its own. So you're simply looking for biochemical interactions that you feel can lead to ammonia toxicity. Now, here is what I want you to do. Before you talk about ammonia toxicity, you have to look for all the avenues, all the possible avenues that could lead to excess production of ammonia, because eventually that's what will lead to ammonia toxicity. So you could talk about excess intake of proteins, which means that you're going to have a lot of amino acids. And if you have a lot of amino acids building up, the rate of breakdown of amino acids will also be high. And we know that is from the breakdown of amino acids that we actually have production of ammonia. So this could basically be a situation where the body is taking in more amino acids and breaking them down into ammonia. So you have too much ammonia such that the rate at which ammonia is produced is higher than the rate at which it's being consumed in the urea cycle. That could also be a possible link to ammonia toxicity. You can talk about the actual step, the actual reaction, the breakdown of glutamate to produce ammonia and alpha ketoglutarate. So this reaction also is very critical because the rate at which this glutamate is being broken down to ammonia and alpha ketoglutarate could also lead to buildup of ammonia, which eventually can lead to ammonia toxicity. You can talk about things that affect the key regulatory enzyme, which is carbamyophosphate synthase 1. So it could be a deficiency, which I would love you to talk about in much detail, how this deficiency comes about. It could be a mere inhibition of this enzyme. If this enzyme is inhibited, it means ammonia will not be converted to carbamyophosphate and will not actually be channeled into the urea cycle. So this as well can lead to accumulation of ammonia, leading to ammonia toxicity. You can talk about, apart from inhibition, you can talk about the deficiency, which is, I think, one of the most common aspects here, leading to hyperammonemia and eventually this ammonia toxicity. And we know exactly, we talked about what happens if you have excess ammonia. Ammonia can actually find itself in the brain where it depletes the alpha ketoglutarate that is present, thereby depriving the TCA cycle in the brain cells of a very, very important intermediate, which is alpha ketoglutarate, thereby leading to damage. So this is just showing how excess ammonia can overflow and leave cross over into the brain to cause that destruction and damage. So I hope this is a bit clear. So what you should focus on when answering this question is you look for aspects that can lead to a buildup of ammonia and eventually lead to ammonia toxicity. So the other question that we probably have to look at is the question on obesity. How does excessive intake of carbohydrates lead to obesity? So again, I'm just giving you clues on what you should focus on. So the carbohydrate degradation starts with this glycolytic pathway, the 10 steps of glycolysis, producing ATP, NADH, and pyruvate. And so we know that this pyruvate undergoes decarboxylation to produce acetyl-CoA, which can combine with oxaloacetate in the TCA cycle to produce the first substrate, which is citrate. Now, at this point, when you have too much of acetyl-CoA being produced, maybe due to excessive availability of glucose in a very well-fed state, you find that there's a point where the amount of citrate becomes too much, and then this actually, the presence of too much citrate inhibits the TCA cycle. So citrate can no longer proceed in the TCA cycle, but then is transported to the cytosol. In the cytosol, citrate is cleaved into its constituent molecules of oxaloacetate and acetyl-CoA. And of course, it is at this point where we begin to sense the connection between carbohydrate intake and obesity, because acetyl-CoA is going to be converted into malonyl-CoA, which is the entry point into lipogenesis, or the process by which fatty acids are being produced. So at this point, the more fatty acids you produce, the more likely you are to go into obesity. So it's pretty much easy, some kind of metabolic integration. And so you just have to focus. How does carbohydrate intake lead to fat buildup? So this is the kind of route that I would love you to actually explain in a little bit more. I want you to explain in a detailed manner, so to say. So I think that's all I had to address for now. If there are any questions, as usual, you can still drop them, and then we'll address them in the next clinic. Thank you very much for watching.